third project to pitch, coming from Turkey, if I'm not wrong. So we see the globalization of space resources. So please allow me to welcome from ŞiraSpace, Ms. Gurur Gaye Gunal, to explain the project regarding space debris recycling. Please, a big applause.
Okay, thank you very much. Thank you very much all for sparing your next 10 minutes to listen our project. Our project is about establishing Space Debris Recycling Center, which is a kind of innovative and out-of-the-borders project for now. In this project, our main target is following huge collaborations with all the companies who can contribute in our designed Space Debris Recycling Center. Now I will bring you a kind of futuristic journey with the video and animations that I'll show you, and you will easily see that our target is being a pioneering member in this industry with this project. We are saying that if you want to be the light to the world, you have to dare to do something which no one has ever done, and you should not stop until you're proud of what you have done. This is our target and roadmap. You can see that our project name is Carina Project. We are planning to design fully robotic and autonomous space station where we can recycle and refurbish inactive space debris and also satellites. As you see, according to the Space Environment Report 2023, there is already 16,990 satellites in orbit, and 2,500 of them are inactive satellites. And still up to now, there are not any alternative solutions to reuse or recycle these satellites in orbit. So our project will be a kind of game changer in this field. As you see, this impact of the satellites are so serious, and they are big threats for the current active satellites. And also, according to the Wikipedia records, there has been 36 incidents which has been occurred because of this inactive space debris, and more than 600 crash in orbit. And the alternative solutions are about burning these debris in atmosphere, which is causing additional, more small particle debris, and same as the laser technology solution, satellite retrievals, or recycling these inactive debris, satellites or debris on Earth are the alternative solutions. But most of them are not that cost effective, and the others are generating more small particle debris, which will be so difficult to clean them afterwards. Our principle in this project is no competition, just collaboration. There are a lot of industry members who can contribute in this project, as its size is quite huge. And under this principle, we signed 25 MOUs with the experts, university professors, and leading companies in this field for realizing this project. Our solution is about capturing this inactive space debris with the help of the electromagnetic nets, which we have strengthened with the neodymium magnets. And on top of the magnet, we will use octopus robotic arms to let it open on top of the item that we plan to capture. And after, the mechanism will close itself and drag it back into station. In the first unit, I want to... Oops. Can you help me to make video work, please?
Which one is it?
Next one.
Next one.
Next one. Next. This. Yeah, thank you so much. About this space station, it occurs from 6 top units and 3 beneath, and it will provide us to use orbital move. We plan to establish it in LEO, in 400 kilometers height. First, initially, we plan to clean LEO debris and after GEO. Here in the first section, after we capture and grab that inactive satellites into space station, we will scan and analyze the structure of the debris that we have captured. And after, in the second part, we will transfer it to another detailed scanning department. In the third part, we will make the separation, and we will break it into pieces, and we will send it to melting furnaces, and after 3D printers, which will provide us an opportunity to print more equipments in space. And then we will send them, if we will refurbish, we will send them to solar panel repairment units, or maybe battery refilling or fuel refilling unit. And then we will be able to deorbit it from the station. And the platform is not rigid, its shape can change. As you see, these are the units of the station which we will use. And the market size, it's around $5,076,000,000 space industry value up to 2023 records. And in this project, it will be possible to recycle or refurbish these inactive satellites. And it will give us a lot of opportunities. Instead of other member states to try to develop these technologies by themselves and spend a lot of money for creating their own solutions in it, we invite them to collaborate in this project all together and share piece of cake all together, because there are enough piece of cake for everyone to share in this project. And also this center, as it will be in the LEO, it can also serve for ISS as a backup center, and also for the active satellites for refilling their batteries and fuels or repairing their solar panels. It can be another alternative. So this will be a kind of space fabric in LEO initially, and after, if it works well, we can also launch it to GEO2 for the other satellites. Regarding its robotic part, I want to introduce you my colleague, Professor Dr. Miguel Olivares Mendez. So he will present you the robotic parts. Thank you.
Thank you very much. Hello, so my name is Miguel Olivares. I'm professor at the University of Luxembourg and space robotics and the head of the Space Robotics Research Group. So I'm supporting the initiative of my colleague Guran in a way that robots, of course, are needed for having this system operative, because we cannot rely on human doing all this work. And of course, it's not working? Okay, well, I can continue. Yeah. So, of course, the idea is to have a fully automated system. So having the possibility of robots to going from one unit to another unit in order to make this whole process of disassembly, then separating parts, selecting what parts are important or be on the right status in order to be reused, and also do the full assembly. So we are currently doing this kind of research at my research group at the University of Luxembourg, and we have a ground facility where we are testing some of these specific activities. As you can see in the video, the conceptual idea is to have the different units in where different activities are done, and then robots can be reutilized in different units, going from one place to another. So.
I may add something. There will be a magnetic rail system which will allow us to move robots from one unit to another. And as you see, all systems will be fully autonomous, and we will connect them to each other with the pipes that we will use. And regarding realizing these parts of the project, we already signed the MOUs with related companies who are already working in its field. And of course, we need to develop some part of the project. And probably we plan to launch our project in 2029 by completing all the R&D parts, prototyping and manufacturing types. Thank you very much for listening. Thank you.